In this video, we are going to learn how to solve a linear absolute value system of inequalities. So we're going to find out what is the solution to each of these systems of inequality, starting with the example on the left. We have y is less than or equal to 3, and y is greater than or equal to the absolute value of x minus 1. Now we'll start with the top equation. Y is less than or equal to 3, and this equation is just going to be a horizontal line at y equals 3. So I'll put several dots, but it's going to be this horizontal line. And it is equal to, which means that it's going to be a solid line. And everything below this line will be shaded. Now, the absolute value equation, the way to graph an absolute value function is to find its vertex first, which in this case will be 1, comma 0, since I'm not adding any k value. If you're considering general form. And then my a value, the number in front, will just be 1, so the slope of the branch to the right is 1. So I will put my vertex at 1, 0, and then I will go up 1 over 1 to the right. And I know this graph is symmetric, so I'll go up 1, left 1 to create that V shape. Again, this is equal to, greater than or equal to, so it'll be a solid line, and I'll shade upwards. You'll actually see here I'll get an enclosed space, because now the overlapped region is right here in this triangle. So when we start to involve these absolute value functions, since they have this bend to them, they'll often create these enclosed spaces for us. Now for the next example, we have x plus 3y is less than 3. So solving that, putting it into slope-intercept form, I'll get 3y is less than negative x plus 3. I'll divide by 3 and get y is less than negative 1/3 x plus 1. So y-intercept of 1, and then down 1 over 3 to find my slope. Do the same thing backwards to create my line, and this time it's not equal to, so I will use a dashed line to represent it, meaning no point along the line is used in the solution. And then I'm also less than this line, so I'll shade everything below it. For my absolute value inequality, I will need to factor out a 2 to start. Give me y is greater than absolute value of 2 times absolute value of x minus 1. So y is greater than 2 times absolute value of x minus 1. The vertex will be 1, 0, and the slope of the branch to the right will be 2. So 1, 0. And then a slope of 2, so up 1 over 1, up 1 over 1, up 1 back 1, create that V shape. And in this particular case, we'll actually have a very small solution set. Now, an important thing to point out with a very small solution set is that we may not have any whole numbered ordered pairs. Maybe only these decimal ordered pairs within these two, because again, I am shading above this V shape, so I only have this tiny little triangle right there in between the two of them. So it's a very small area of solutions. So maybe the correct solution would be at 1, 0.5 in order to find one that works to test later. Now this last example, you don't see the system of inequalities, but this is one of my favorite inequalities to graph. I like to call it the bow tie inequality. Because first, I would need to get rid of the absolute value bars around y in order to graph. Which, if you can remember this, that would make this, since this absolute value is less than something, it'll be y is in between negative absolute value of x and positive absolute value of x, which gives us two inequalities. One being y is less than or equal to absolute value of x, and on this side, y is greater than or equal to negative absolute value of x. So if I were to go and graph both of these inequalities, first, absolute value of x as a vertex at the origin and a slope of 1 to the right, if you remember our parent functions. When I first introduced absolute value graphs, and that would be a solid line. And it's everything shaded below since it's less than. And the other one will be negative absolute value of x, which means that since we're multiplying by a negative in front of the absolute value, this graph will be reflected across the x-axis vertically. So same vertex, but reflected. And then everything above that line, which leads me to these two shaded regions on the left and on the right, creating a little bow tie shape in our shaded region. And again, the reason why this becomes a system of inequalities is because y has to be both less than absolute value of x and y has to be greater than or equal to negative absolute value of x. And that is how you solve a linear absolute value system of inequalities.